Okay, so 7.4, evaluating logarithms and graphing logarithmic functions. We have a lot to go through today, but it's a lot of, the beginning is very easy. It's like memorization. It's a pattern to things. The end is graphing, and it's a little bit, it's similar to the graphing you've been doing, okay? Lots of plug and chug. Logarithm of y with a base of b. See how this says log base b of y equals x, okay? And over here, it says b to the x equals y. So here's the deal. I can change things from logarithmic function into exponential function back and forth so that I can solve them easier, okay? Do you notice this b right here? What is this considered on a logarithmic function? Log base b. Good. And this is considered your base also, right? Your base of b raised to an x power. So here's the deal. It's like that song. Everything is about the base. It's all about the base, okay? That's how I remember. That's how I remember this, because it is all about the base. Everything wraps around that base, and if it is about the base, that's how I decide where things shift. So look. See how this says log base 2 of 8 equals 3, okay? I can rewrite that into exponential form, and I say 2 to the third power is 8. Yes, okay? Base, base. This is my exponent, exponent of, okay? Log base 4 of 1 equals 0, so 4 to the 0 power gives me 1. Log base 12 of 12 equals 1. 12 to the first equals 12. Okay? Log of 1/4, log base 1/4 of 4 equals negative 1. Okay? That works out because what do you have to do when you have a negative exponent? Flip it. So 1/4 to the negative 1 equals 4. If we can move our logarithmic form into exponential form, we can solve for unknowns. So if we didn't know if it said log 2 of 8 equals 3, I would change it to say 2 to the x equals 8. What? 2 to what power gives me 8? And you can solve. Okay? Oh. So, no. So tell me how this works. Log base 3 of 81 equals 4. What would you change that to?
4. 3 to the 4th.
Oh, yeah, that's fine.
Okay, so 3 to the 4th equals 81. Okay?
7 to the 7th.
So what do you have when you have log base 7 of 7 equals 1?
7 to the first equals 7.
Good. 7 to the first equals 7. What about log base 14 of 1 equals 0?
14 to the 0 power equals
14 to the 0 equals 1. And then log base 1/2 of 32 equals negative 5.
Negative 5 to the...
Nope.
No, 1/2 to the negative 5 equals 32.
1/2 to the negative 5 equals 32 because you have to flip the fraction because it's a negative exponent, yes? Okay. So that's the first step of what we're doing. You're literally taking those and transferring them into exponential
So it's
form.
just like...
Yep. Okay? Now, do you see how this set of directions said rewrite, yes? This set says what?
Evaluate.
Evaluate. Evaluate means what?
Solve.
Solve. So do you see how this doesn't have an equal sign like these did? Okay, correct? So what we're doing is this. Let's take log base 4 of 64, okay? Now, rewrite it like we would over there. We don't have an equal sign, so what do you think we would put?
X.
X, good. So what's my base?
4.
So 4 to the
X
equals,
64.
and they want to know what X is.
33.
Right, because 4 cubed is 64, okay? And if you don't know that it's cubed off the top of your head, you can always do a factor tree. 8 and 8, 4 and 2, 4 and 2, and 2 and 2 is 4. So you have 1, 2, 3 of them, yes? Okay. Now, what about log base 5 of 0.2? How does that change?
5 to the x power equals 0.2.
Okay, 5 to the x equals 0.2. Now, here's the deal. You said 0.2 is what?
1/5.
1/5.
So it'd be negative first.
So it would be -1 because I've got to flip it, right? Okay, so it's 5 to the -1 equals 0.2. Good.
So we just have to recognize that, there's no,
So you have to recognize, first of all, well, it went from a large number to a decimal, right? So what I would say is, if you don't know what 0.2 is, I would change it into 20 over 100.
and then
Reduce it down, you'll
Okay.
realize it's 1/5.
Yeah.
Does
So
that make sense?
Some of this require like a lot of written out work, you could just look at something and tell,
Correct.
and you can just put down.
Correct. I want it written out to this extent.
Yeah.
Yes, but yes, Olivia. So if you are good with math facts, this is gonna be much easier. Devin, wake up. So if I have log of 1/5, log base 1/5 of 125, how do you transfer that?
1/5 to the negative third power.
1/5 to the x power equals,
125.
now, you see how this is a fraction? And it goes to a whole number, which means I need to
-3.
flip it, right?
-3.
So you're gonna get -3. Does that make sense? You have to use some logic here.
Okay. That seems a bit more easy.
Okay, and then you have log base 36 of 6, which means, what does that transfer to?
It's a fraction, so it'll be 1/2.
Okay, let's get everyone else there, let's talk about it. It means that I have 36 to the x equals 6, right? So I went from a whole number, a large whole number, to a smaller whole number, okay? So I know it's not negative, because they're still whole numbers, one's not a fraction and one's not a whole number, okay? But I need to then ask myself, how does 36 and 6 relate? What do you know about 36 and 6?
6 times 6.
6 times 6. So 6 is the square root of 36.
Yeah.
So a square root exponent is represented in what form?
1/2.
A fraction. So this is going to be, x is going to be 1/2. Because if I raise 36 to the 1/2, that means I'm taking the square root of 36. Yes?
Wait, oh, yeah.
Okay?
It'd be 36 divided by.
So if it is a whole number to a smaller whole number, it means it's going to have a fractional exponent. If it is a whole number to a decimal, it's going to have a negative. If it is a fraction or a decimal to a whole number, it's going to have a negative. Okay? But a large whole number to a smaller whole number means it's going to be a fraction exponent. Okay? Then we have things like this. Okay? In your calculator, when you press the log button, it has a base of 10. Okay? You see it just says log, but it has a base of 10. Log base 10 of x. It's the same thing as log x. Okay? When you use natural log, it has a base of e. So log base e of x equals the natural log of x. So natural log has a base of e, and log has a base of 10, okay? You just have to know that fact. It's something that just happens. Because of that, I can then solve these things in my calculator. How do you think you're going to do log 8? What are you going to do?
Press log, then press 8.
Yep, press log, then press 8, press enter.
0.9, what do you want to
Always round to 2 decimals for me unless it tells you.
0.90.
0.90. So log 8 equals 0.90. Okay? And I don't think I took attendance. So this should be really easy. What's natural log of 0.3?
Negative 1.2.
It's negative 1.2.
Wait, what symbol?
Negative
is that on
1.20, yeah. What?
Which symbol is that on our calculator?
The one that says ln.
Okay,
ln.
I thought that was on ours or something.
Okay, ln. Okay, so the expression one should be easy because you're literally plugging them into your calculator.
Can that be like 50%?
No. Listen, Will, the first 3 sections are all plugging into your calculator. So yes, it is like 50% of your test.
On top of that would be easy.
Okay. The wind speed S in miles per hour near the center of a tornado can be modeled by S equals 93 log D plus 65, where D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado center. What do you got to do there?
Plug in 220 for D.
Yep, that's all. So S equals 93 log 220, and when you plug that into your calculator, make sure you end your parentheses before you put plus 65. What do you end up getting?
282.85.
So, yes, 282.85, and it is miles per hour, correct? So make sure you always put your units with it too.
Did it actually happen?
It did actually happen, yes. That's like an actual statistic. Okay, now, don't get confused by all the letters, let's talk this through. Remember we did inverse functions on the last chapter? How do you prove that an inverse function, how do you prove that two functions are inverse of each other?
When you can make them.
Plug it in, you said.
Yeah, so like you take f of x and you put f of g of x, you plug g into the x of the f, and vice versa. And they both come out to x, correct?
Yeah.
Now, same thing happens with logarithmic functions. Look, if you know that your log base b of x is your inverse function, okay? And your exponential function, b to the x, is your natural function, your original function. If I plug them into each other, if I plug g of f of x in, then I have log base b to the b of x, yes? Okay, don't pay attention to that yet. Log base b to the b of x. When you have, look at this, log base 7 of 7, what do you end up getting?
1.
1. So if you have log base b of b, what do you end up getting?
1.
Or in this case, what's left?
X.
X. So it's the same as inverse functions, you get x out, okay? If I plug in b to the log base b of x, I get x out because b and log base b cancel out. They give you the number 1. If you plug in natural log, what goes with natural log? What goes with natural log? What's the exponential graph for natural log? We did it in your last lesson.
E.
E. So if I have natural log, okay, and then I have e to the x power, that means that these cancel and give you x. If you have e to the natural log of x, these cancel and give you x. Because natural log with a e, or e with a power of the natural log gives you 1. Just like log with the same base as the base with the power gives you 1, okay? So they have inverses. The exponential and the logarithmic function are inverses of each other when they have the same base. So here you have 10 to the log 4. So what do you get when you simplify that? Yeah, Korea's right, you get 4. Because what base does 10 automatically have, or does log ever automatically have? 10. So this is 1, which gives you 4. If you have log base 5 of 25 to the x, okay, and it wants you to simplify. Your base is what? Here. 5. Can you get 25 into a situation with the number 5?
Yeah.
Yes, it's what?
5.
It's 5 squared, right? So I'm gonna change this to say log base 5 of 5 to the 2x, because when I square it, I multiply those powers together, yes? Now what happens here? The 5 cancels and you get,
No.
what's your exponent that's left? What'd you say? Did you say it, Dave?
I said 2x.
Yeah, that's right. You get 2x. I can't hear you, I'm sorry. So log base 5 of 5 ends up giving you 1, and you get 2x as your solution, as your simplified answer. Okay? So you want whatever this number is to match your base so that you can cancel them out. Just 4 more slides.
Oh, Joe, Miss Peters.
How do you find the inverse of a function?
You flip the x. and
You
y.
flip x and y and you resolve for
X.
Which.
Y.
Resolve for y. Flip x and y and resolve for y. Now listen, on part A, that won't work because you don't know how to physically do it yet. So you're gonna memorize a pattern, okay? And then later, breathe, up. And then later, we'll talk about how we can actually solve that using logarithmic functions, okay? But you don't wanna know that yet. So y equals 6 to the x, okay? If I want to find the inverse of that, this is what you're going to do. Okay? You're going to say, well, normally you would switch x and y, and that would put y in what position?
Would be
It would be in the exponent spot, correct? Okay. So then it would say x equals 6 to the y, yes? Okay. And because it says x equals 6 to the y, when you would plug in numbers, you would be plugging them into what?
X.
No,
Right, Y.
into the y position, correct? Okay, so here's the deal. When we find the inverse of this, because you would switch it to say x equals 6 to the y, if I wanted to resolve for y, I have to bring log into this, yes? Okay, and whatever I do to one side, I have to do to the other. What is your base here? That's what you need to focus on. What's your base?
6.
Okay, so how can you get rid of a base of 6? You would need
6
log
to-
6. You would need log 6. Okay? So I would need to say log base 6 of 6 to the y equals, and I'm going to come over here and do the same thing. Log base 6 of x. Now here it simply, so you get y equals log base 6 of x. There's your inverse function. Does that make sense? Okay? Now, let's talk about the other one. You have y equals natural log of x plus 3. What goes with natural log?
E.
E. So first, we want to find the inverse, so what are we doing with x and y?
Switch.
Switch them. So you get x equals the natural log of y plus 3. Now, Will just told me that e goes with natural log. So to get rid of natural log, I have to take e and raise it to the natural log. Okay? E to the natural log of y plus 3. And whatever I do to one side, I do to the other. E to the x. Do you see that? Okay, so e and natural log cancel because it's 1. And you get y plus 3 equals e to the x. How do you get y by itself?
Subtract 3.
So e to the x minus 3 equals y. There's your inverse function. So when you're finding the inverse of an exponent or of log, you have to use, if you have of an exponent, you have to use log to solve. If you have natural log, you have to use e to solve.
Right.
Okay? So we're rearranging those. Now, this is a lot of confusion in a picture to me. So we're gonna talk through this in a little bit easier format, okay? So your functions in red are your logarithmic functions. Do you notice that on both sides? They're your logarithmic functions. Your functions in blue are your exponential functions. On the right, you have, do you have growth or decay happening? On the right picture.
Decay.
Decay. And on the left, you have growth, which we have graphed both of those in 7.1 and 7.2, yes? Okay, what? Okay. We have graphed both of those in 7.1 and 7.2, okay? Now, we're graphing the inverse function of that. That's all we're doing, by adding log to it, okay? So, you have to understand that they correspond with that exponential function. So, because this exponential function curves, my axis of symmetry goes through y equals x. It's a diagonal axis of symmetry, and this would flip over to give you logarithmic function, okay? Because remember, your inverse function is opposite of what the normal function is. Here, my axis of symmetry still goes through y equals x, okay? But when I flip this one, remember that I can't have what? when you're dealing with log or with exponential function, what type of, things can you not have?
Negative.
I can't have negative inputs, right? That's why that graph looks so funky, because it flips it,
Right.
right? If I were to, when I flip this, listen, when I flip this portion over this axis of symmetry, it flips to this section, yes?
Mm-hmm.
When I flip this portion over this axis of symmetry, it flips up to this, yes? If you take piece by piece, okay, so it looks a little different. Now, let's talk. How would I graph log base 3 of x? Can I graph that?
Yes.
Okay. Can you graph something, what base is on your calculator? 10. Is that a base of 10?
No.
No. So I need to change that into an exponential form so that I can graph it. So if you have y equals log base 3 of x, how does that change into exponential form?
You would have to take the base and put it to the x, so y equals 3x.
No.
3 to the x, I mean.
Nope.
Oh.
3 to the y equals x, because look over here, remember? Base to
Yes.
what it equals is then that. So, listen to me very closely, because this is where you mess up the most. Number one mistake, I make it too. When you are plugging numbers in for these, you are plugging into y, which means your output is your x, which is different than how you graph any other time, correct? You usually graph by plugging into x and you get a y output. So if I plug the number 0 into here, I actually have an ordered pair of 1, 0. If I plug a 1 into here, I have an ordered pair of 3, 1. Do not reverse those numbers, your graph will be wrong every time. You are plugging into y on this, not into x. You're plugging into y, okay? And then I would graph from there. Now, how would you change the next one? Y equals log of base 1/2 of x. What would you do?
1/2 in parentheses to the y power equals x.
Right, and once again, I'm plugging in for y, getting outputs for x, okay? The last thing we need to look at is this, translating. Remember when we translated exponential functions, we only focused on the main portion and then we added or subtracted to all those points, doing it the same way. Okay, so what does that 3 tell me with the x?
It's going down.
Nope,
Left.
left 3. What does the 1 tell me with the y? Look, the 1 tells me what for the y, it's going
Up.
up, okay? And you have this, we're gonna focus on this. You're gonna focus on just this portion of the equation, got it? Change that into exponential form, how's it change? Somebody besides Will, how does that change? Log base 2 of x equals y. Change it so we can graph it.
Oh,
2,
to the x.
2 to the
Oh wait, to the y.
y equals x. Now, I would,
You're taking the inverse?
I am taking the inverse, yes. So now, I would plug numbers into there. Once I get those numbers out, so let's say I plug 1 into y, yes? That means I get 2, 1, correct? I plug 0 into y, that means I get 1, 0, correct? Now, I have to come back and I have to shift it left 3, up 1. So x equals minus 3, y equals plus 1. So this point changes to negative 1, 2, yes? This point changes to negative 2, 1. And then you would graph those points. It's the exact same thing we've done in 7.1, 7.2, and 7.3. Except for first you have to change it into the inverse function so that you can graph it. And you are plugging into